In this second part of discussion on database security, we're going to focus on encryption and then also on firewalls. Okay. So what you do with a database is you store some information and then you want to make that information available to some people, and those people may not be sort of in the same room. They might be on the same campus, or they might even be like off the campus. So that data is being both stored and sometimes it is in transit. And a way to secure data, either storage or in transit, is encryption. So you take your information, which is somewhat readable, and that's known as plaintext, and you're going to transform it, sort of perform some operation on it, and make it less easy to read. And that will be the ciphertext, and that will be the form that you will either store or transmit. Okay. So the data, even if it's like text data, like people's names or something like that, really inside the computer, uh, everything is binary, is ones and zeros, is effectively numerical. And that means that encryption is basically just like a mathematical operation, some mathematical function. And so then if I apply some mathematical function to the data, that gives me some new answer, some new data. And then if the function happens to be invertible, that means I can get back to the original data. I can decrypt the message. So not all functions have that property, but enough do so that we can move in one direction and then get back. So we have a reversible function, an invertible function. We can encode and decode. We can encrypt and decrypt. And typically, these mathematical functions have some parameter, and we'll be referring to this as the key. And so then, for us to communicate, I will tell you the operation that I'm going to use and the parameter. Okay, so a simple example of this is the Caesar shift. So we can take a message and break it up into individual characters, letters, and we can think of those letters as numbers, either by their position in the alphabet or the ASCII code for the letters. And then we can perform a mathematical operation on that. In this case, the mathematical operation will be addition. And let's say that our key, the parameter we talked about, is a 3. So I will take, say, a word like cat, and I'll take the C and I'll add 3 to it. So C will move to D, will move to E, will move to F. And so cat will turn into FDW. And so that is uh, less readable than the word cat. Um, and then there's an inverse operation, and you can say either that it's subtraction, the inverse of addition, or you could even say that it's the addition of a -3. But either way, you sort of know how to get back. And so FDW can be turned back into cat. So we moved from plain text to ciphertext, and then from ciphertext back to plain text. Okay. So Caesar shift is what we call a symmetric encryption. So we know the encoding operation pretty much tells us the decoding operation, and knowing the encoding key or parameter tells us the decoding. So I could say with Caesar shift that the operation is addition and subtraction, both of 3, or I could say it's addition and 3 and -3, however you want to think about it. But sort of the operation similar, and knowing one key implies knowing the other. When this is not the case, when the functions are more sophisticated, and we're not going to worry about uh, what kind of functions these are. They exist, but they're not easy to describe, so we're going to leave that out. Um, but if knowing one key one process and one key does not tell you the other process or key, then the encryption is said to be asymmetric. This is then more secure because of it takes more time. That's not what makes it more secure, but it does take more time. But it is this that knowing one is so being having the key to encode the message does not imply that you have the key to decode. And so that gives you more security. And we're going to start talking about uh, some scenarios, some different ways of using this asymmetry. Um, One way of using the asymmetry is to combine it with the symmetric approach. So the you have to have some agreement or communication, even in symmetric, of the key. And so then one way to use asymmetric is because it's more secure to use the asymmetric encryption to encode the key of the symmetric. So the bulk of the communication may be the simpler symmetric encryption, but the communication of the key for the symmetric encryption will use the asymmetric encryption. Um, and so it should be sort of hard for somebody to figure out the key. Okay. So again, in asymmetric encryption, we have some operation and its inverse. Each has a parameter. We're going to call them the keys. And these uh, two keys, knowing one key does not know the other. And we are going to sort of give the keys different names and sort of use them in different ways. So let's start to talk about that. So I want to use this. So every user uh, that wants to communicate in this asymmetric way will sort of, apply for and receive a a private key and the corresponding public key, the one direction and the other direction. And one is designated private and the other is designated as public. And so then the communication will be between two users. So there are two possible sets of private and public key. Okay. So now let's say that I want to communicate with you and I want it to be private. So I want only you to be able to see the message. So you have a private and a public key. And as it suggests, the private key you've kept to yourself, as I've kept my private key to myself. But the public key is sort of it's published to the world. It's out there, it's known. So then if I want to communicate with you privately, I will go out to this place where I can find your public key, and I will use that public key to encrypt my message and send it. And other people might be able to pull this message off the internet somewhere, but you're the only one with with that private key that undoes that your public key, and so you should be the only one who can decrypt the message. So it is uh, only you should be able to decode the message. So it is private. We can turn the process around and use my keys instead of your keys. So again, I have a private key and I have a public key. So now what I can do is I have a message I want to send and I encode it with my private key and send it out. And then again, anyone in the world can, possibly grab this message off the internet. And if they know it's from me, they can use my public key and decrypt it. So it's not private, but it will be known to you and to anybody else who grabs this message, then it came from me because it was decrypted with my public key, and presumably that could only have come from my private key. So this is a means of authentication. So you know the message came from me. Maybe anybody in the world can read it, but we know it came from me. So now we can play both games. And so now we have Mary and John instead of you and me. We'll have Mary and John, and they want to send a message. So Mary is the sender, and John is the recipient, and Mary's going to encrypt a message with John's public key. But before she sends the message, she's going to do a second encryption with her private key. Now the message goes out onto the internet. Uh, any number of people might be able to grab it, including hopefully John. And then the last thing that was done in the message was Mary's private key. So if one uses Mary's public key, then we know that that the message was from Mary. So we have some authentication of Mary. And then we do a second decrypting, and this time we're decrypting it with John's private key, and then only John can do this. So it is, so we know we have the the privacy, then only John can see the message, and the authentication. We know that it's from Mary. Of course, we did this public private encryption twice, so it's a, you know, computationally complex thing, and we had to do it twice. So there is some uh, penalty or computational penalty there. Um, Sometimes, it can get more complicated than that. That's just a simple sort of scenario. But sometimes the two parties don't know each other, and but there can be established sort of what we call authorities. Sort of they are the like institutions, groups, companies who this is their job is to provide sort of secure communication, and so then they will help like mediate this. So they are known as certificate authorities, and um, they will help you with this verification and sort of provide a digital certificate. Okay. Now on to the idea of a firewall. So we're imagining we have the database, and then we want to make it accessible to some other computers, maybe on the work site, maybe even off the work site if people are going to work from home. And so within our network, um, and this can uh, protect things other than just the database, but it's will be part of database security because what's flowing around is information, and some of it came from the database. But a firewall can like sort of look at the traffic coming in and out and sort of control it. So a simple version of a firewall is packet filtering. So information is sent by packets. Um, so if you are, if we say that sending packets is sort of analogous to sending mail, then having a firewall is like the mail being censored. So we are going to have packets and look at something in these packets and say what is allowed out, what is allowed in. That can be based on um, where they're coming from, where they're going, what kind of thing. So any the information within a packet is all sort of there to be censored. Are we going to allow it through? So this can be part of a sort of network security, which is then going to be part of database security. So we're trying to prevent outsiders from probing our computers, uh, flooding our network. and attacking computers in various ways. Okay. So typically, in a network scenario between an enterprise's internet and or intranet and the sort of global outside world internet, there is a thing called a router which manages the traffic. But with a firewall, especially with the sort of packet filtering idea, is you you give the router some additional functionality in addition to just getting things from one place to another. It has this extra censoring job of, allowing and blocking. So the firewall and the router are sort of a team, and they are determining whether or not to forward. And the messages may be coming into the network or going out of the network, but what a router does is like forwards the traffic. But the firewall part of it is going to make decisions whether or not to forward. Um, so there are the destination, the source IP, which computer did it come from? The destination IP, where's it going? There's just basic direction in and out. There are services, different types of packets, and that can be used to filter. I'll allow this service, I won't allow that service. There may be just something based on time. So we're not going to allow our information out at non-business hours or something. Okay. We can also keep track of things. We can audit things. So that's another thing that the firewall can do. So keep track of what it's blocked, but also what it's let through. It can look for, you can train it to understand what a virus looks like, though they're always changing, but sort of give it some ideas of these are things you shouldn't let in. It can look for these authenticating measures that we talked about. Um, and then if you have a sort of pair of firewalls, so you have maybe somebody's like private home network, and then like the enterprises, the companies sort of campus network. And if they each sort of have a firewall and agree on an encryption scheme, then you have what's called a virtual private network. So you have um, the firewall sort of managing an encryption scheme and keeping your data into like a form that, to get from that person's home network to the sort of on-site campus, it's going out, the packets are going out, the information's going out just to the world, but there's an encryption scheme that the world can see it but not understand it. And this is more important as more and more people um, work from home, either all the time or some of the time. And so that is, in the last many years become more and more common. So a VPN is a way to manage, to have security of all of one's network assets, and the major one being, of course, the database. So that's it for this one. Thanks much for your attention.